All right, so scalability. Like we mentioned before, right? It's hard to tell how many customers you're going to have at a specific time of day. Just like at a coffee shop, you might need more employees during the rush hour. Well, same goes for an application, right? If you have more customers, more users, more clients, literally, right? Clients from client server model, then you're going to need more compute resources. So the ability to scale up and down, or in or out, the amount of resources you're using is crucial in order to meet demands. So scalability refers to the ability of a system, application, or infrastructure to handle increased or decreased demand by adjusting resources dynamically. It involves beginning with only the resources you need, designing your architecture to automatically respond to changes in demand, and then scaling out, which means using more, or in and using less resources based on that demand. If you want the scaling process to happen automatically, AWS does have an answer. It's a EC2 auto scaling tool. So Amazon EC2 auto scaling, what is it? It basically just allows you to automatically add or remove EC2 instances based on the demand of your application. So by automatically scaling your instances in or out, remember in means less, out means more, you can maintain a greater sense of application availability. That means your users, or maybe other services, right, communicating with your application, whenever they are giving it more work to do, it's going to be able to handle that work. It's going to be available to do that work. Same at the coffee shop, right? If you have way more customers during the rush hour, during the lunch hour, then you should have more workers. So more instances, more workers, same thing. There are two scaling approaches. You can use one, you can combine them as well if you want to scale even faster. There's dynamic scaling, which is, hey, 10 more customers walked in, so I'm going to add one more, worker, or, I don't know, 10 times more computation was performed, so we're going to throw in one more instance. There's also predictive scaling, which is a little bit more advanced. So it's going to automatically schedule the right number of instances based on predicted demand. So it's going to use the historical demand to try to predict how much you're going to need next week, the next day, the next hour, etc. You can combine both to make sure that even if you don't predict the right amount of computation, right, you'll still deliver it right if it does change suddenly. So it's all about meeting demand. So dynamic scaling, just like I mentioned, it's automatically adjusts the number of instances or workers based on real-time changes in demand. So you can use CPU usage, network traffic, or any custom metric. So it's up to you when to scale up. So use cases are workloads with unpredictable or variable traffic patterns. So again, does the amount of traffic data that you have to process, or maybe the amount of users change, the amount of requests changes, that's where dynamic scaling can work. So an example of something that might change on a dime like that, right, in terms of demand, it could be a web application, right? So you have your app hosted on the web, sudden traffic spike. So you had a marketing campaign. You got a bunch of people coming in, right, for the sale or for the promotion. So more requests coming in for your website. Dynamic scaling is going to add instances to handle that load. If you don't properly handle that load, you could crash your application. Predictive scaling, so it's going to forecast, right? It's going to find patterns in your previous usage to figure out, hey, when's the best time to scale things up in order to avoid delays in scaling. So you don't want to wait for the dynamic scaling, right? You want to get ahead of it. Predictive scaling can be a good way to do that. So maybe you have an e-commerce site that every Friday evening, right, you're gonna expect a bunch of customers coming in. Predictive scaling is going to add instances before the spike even occurs. So it's not going to wait for that increase in demand. If you put them together, then you can handle workloads with both predictable and unpredictable traffic patterns. Dynamic's going to handle the unpredictable part, and then predictive is going to handle the predictable part. So applications that need to balance proactive and reactive scaling. So another video, so scaling part 2, go ahead and watch that, and we'll jump right in right after the video.